similar to what we said for two-dimensional space, I'll just write one sentence here. The sufficient and necessary condition for the equilibrium of an object is summation of forces applied to it should be 0. Now in this case, since we are in three-dimensional space, it means summation of forces in x direction should be, well, let me write it this way. I plus summation of forces in y direction j plus summation of forces in z direction k should be 0. That means summation of forces in x direction should be 0, summation of forces in y direction should be 0, and summation of forces in z direction should be 0. Now in this case, we're not sensitive about positive, negative, like before when we were writing for two-dimensional space. We were taking, let's say, we had to come up with this assumption. You know, when you write this summation of force in x direction is equal to 0, summation of force in y direction is equal to 0, because we need to know which direction we are taking as positive. So we're usually saying, okay, upward positive for y and right direction positive for x. But in this case, this is in three-dimensional space. The final result gives you the direction. Right? You have your x, y, z components, axes. Based on that, you find the components and the resultant force. Well, depending on which one is bigger, positive or negative for each specific direction, you get positive or negative in that direction.